Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 42 for February-March 2024, Mechanics. Question 1 is coming from Kinematics, motion in a straight line. They are saying the displacement of a particle at time t seconds after leaving a fixed object O is s meters. The diagram shows a displacement time graph which models the motion of the particle. The graph consists of 4 straight line segments. The particle travels 50 meters in the first 10 seconds and then travels 2 meters per second for a period of 10 seconds. The particle then comes to rest for a period of 20 seconds before returning to its starting point when t is equal to 60. Find part A, the velocity of the particle during the last 20 seconds of its motion. Now, we know that velocity is the rate of change of displacement, okay? So, if it is the rate of change of displacement, that simply implies that v is equal to the change in displacement over the change in time. Since this is displacement time graph, the change in the displacement, that is the vertical, and then the change in time, that is the horizontal, then that implies that speed or velocity is going to be the gradient of that line segment. Now, we shall have the final, because the last 20 seconds are here. The final is this one here, which corresponds to the 0 here, okay? And then the initial is this one here. So we shall have 0 minus s, then divide by the time taken there is 20. But then we can get this s here, the value of this one here, the s, okay? We can get it because they said somewhere that then travels at 2 meters per second for a period of 10 seconds. It is here. That means the gradient of this one here, of this line, is the one that is equal to 2. So if I have the s here, let me actually put it there. If I have the s here, okay, that means we can have that gradient s, then minus 50. That one is going to be the gradient here. Okay, the change in the y here, or the change in the displacement, then divide by the time taken, which is 10. So divide by 10, then this one is equal to this 2, the speed. Remember, the gradient is the speed. Now, when we cross multiply, we shall have s, which is equal to 2 times 10, that is 20. Then we shall add the 50, which will give us a 70. That means I will come here and I say negative 70, then divide by 20, which will give us negative 3.5 meters per second. That is that. Then part B, sketch a velocity time graph for the motion of the particle from from t is equal to 0 to t is equal to 60. Now, let's look at these intervals here. From 0 to 10, the first one there. From 0 to 10. What is the velocity there? Remember, it is the gradient. So the change in the vertical, we can see it is this 50. Then we can divide by the horizontal. The change in the horizontal, which is 10. So 50 divide by 10. That one will give us a 5, right? So that is 5, okay, meters per second. And then, which other one don't we have? This one was given as 2, now this one is 5. And from 20 to 40, of course here, since displacement is not changing, the particle is, I think, at rest, okay? Let's say the graph consists of 4 straight lines. The particle travels 50 meters in the first 10, then travels at 2 meters per second for the period of 10. The particle then comes to rest for a period of 20. You see this one? I'm going to put our v here is equal to 5. Then our v here is equal to 2. Here v has to be equal to 0. You see that? Okay. And then we have seen here v is equal to negative 3.5. So I will go here and I say for 20 to 40, our v is 0, okay? And then the other one is from 40 to 60, then V is negative 3.5. Now I will draw axes here and then I sketch. After that, I will mark, I'll put the arrows where these ones are increasing. This is velocity in meters per second. Then this is time in seconds. And then we shall mark, maybe this is 10, this is 20, 30. For the vertical one, I'm interested in the 5, so I'll just put a 5 here. There is a 2, maybe 4. If this one is 6, then 5 will be in the middle. If I want, I can add those ones there. Then there is negative 1, negative 2, negative 3, negative 4, then negative 3.5 will be here. Now we have from 0 to 10, that is 5, and it is constant, okay? It is constant, so it has to be a horizontal line, 0 to 10. So I'll go to 5, then I draw a horizontal line, which corresponds to this 10 here, 10, and then the other one from 10 to 20, we are seeing 0, 10 to 20, 10 to 20, 10 to 20 is a 2, not 0. So 2, we shall come to 2 here, and then we draw that. Then also, I can put that. And then next, we shall have from 20 to 40, we are seeing a 0. So I'll draw here. In fact, let me make it bolder on this axis. So it is that one there. And then next we have from 40 to 60, that's a negative 3.5. This is the one here. Now I need to put off these. It's from 40 to 60. So that is going to be our diagram there.